Hey everybody, Mr. Covey here, and today we're going to be talking specifically about how to find more angles related to circles. So not as much lengths, but angles. We're going to talk about this in 4 different real situations here, a couple of which you are already familiar with. Okay, so basically there's going to be 4 formulas that you need to remember that are going to help us to find certain angles depending on the setup that we are looking at. The first couple you are already familiar with. So the first one is a central angle. And the important thing to remember about a central angle is its vertex is at the center. Okay, so if you have an angle that's vertex is at the angle, then that, the vertex at the center, then that angle is the same as the intercepted arc. So that angle would be 80 degrees. It's the same as the arc that the angle cuts. Remember, that's what intercepted means. It means that angle that it cuts. Okay, the second situation is an inscribed angle. I want you to make sure that you pay attention to the fact that for an inscribed angle, the vertex is on the circle. It's on the outside of the circle. In that case, the measure of the angle is 1/2 of the intercepted arc. And we've talked about this before as well. One thing I want you to note is that this picture down here, that angle ABC still counts as an inscribed angle. It still fits our definition of the vertex falling on the circle. And in this case, it is this arc that is our intercepted arc. So our angle would be 1/2 of that. So our angle is 60 degrees. So that still falls under the category of an inscribed angle. Be careful about that situation. Okay, third formula here is new, and this is for a situation where your vertex is in the circle. Your vertex is in the circle, but it is not the center. If it is the center, then your angles become central angles, but this is where it's inside the circle, not in the center. In this case, to find one of these angles, it's 1/2 of the sum of the intercepted arcs. So if you look at those 2 chords there, they intercept that arc, and they intercept that arc. So to find angle X, you simply take 1/2 of the sum of those 2. So X would be 120 degrees. Note that those 2 angles are vertical angles, so they are both 120 degrees. Okay? Fourth formula covers several different situations. The thing they all have in common is, again, we're referring to where the vertex is for all of these. In all 3 of these cases, the vertex is outside of the circle. So that's really what I want you to look at, is where the vertex is. All 3 of these situations, they look a little different, but the vertex is outside of the circle. And in all 3 cases, we're going to take 1/2 of the difference between the intercepted arcs. So the previous one was 1/2 the sum. These are 1/2 the difference. And for the situations, you just have to be careful about what we mean by the intercepted arcs. So in this case, here's the one arc. Here's the other arc. Subtract them, take 1/2 of it. X is going to be 80 degrees. In this case, it's clear that that and that are the intercepted arc. The difference between them is 60. 1/2 of that is 30. And then here's our third case where instead of having 2 secants like we did here, or 2 tangents like we did there, one of them is a secant and one of them is a tangent. Still follows our rule that it's identify the 2 intercepted arcs. The difference between them is 70. 1/2 that, you get our angle, which is 35 degrees. The name of the game with this, guys, is just identifying where the vertex is so that you know which formula applies. So in this first one, C is the center. Oh, okay, so I'm using my central angle formula. Measure of arc AB, well, that's just going to be the same as the central angle. So that's going to be 54 degrees. Measure of arc BD, Well, since AD is a diameter, it's going to be supplementary, those two angles, and so that arc will be the same as that angle, 126 degrees. Okay? Second situation, C is still at the center. Straight line, so they're going to be supplementary. Angle C, measure of arc GE is going to be the same as that angle, so it'll be 75 degrees. Measure of arc EF will be 105. Down at number 3, angle 1 is a central angle, so it's going to be the same as the intercepted arc, so it'll be 120 degrees. Note that since this triangle has 2 of its sides as radii, it will be isosceles. So those 2 angles will add up to 60. 60 divided by 2 is 30. Each one of those angles will be 30 degrees. So measure of angle 2 will be 30 degrees. Okay? Last one here. We got a triangle here, so we know that that angle is going to be 78 degrees. To find the measure of arc IJ, this is an inscribed angle. We want to find this arc. That's an inscribed angle because its vertex is on the circle. So we're going to have to double it to get 90 degrees. We want to find the measure of arc JK. I want to find this arc. Again, we're looking at an inscribed angle. Double it. 114 degrees. And if we want to find the measure of arc IK, we're looking at this inscribed angle. So we're going to get that arc is 156 degrees. Okay, just make sure you identify that we are working with inscribed angles in this problem as opposed to central angles as in the previous ones. Okay, I want you to take a couple minutes now to do 5, 6, 7, and 8. Okay, so here's our answers here. Just to go through them real quick. If we want to find the measure of arc MN, note that these lines are parallel, so we have alternate interior angles. This is an inscribed angle. We need to double it to get arc MN. To find arc ML, note that arc MN and arc ML, since LN is a diameter, must add up to 180, so ML will be 94. In number 6 here, we have vertical angles. These 3 angles form a triangle, so angle Q must be 70 degrees, and then angle Q is an inscribed angle for arc SR. Double it to get 140. Okay, in number 7 here, we need to identify that we're dealing with the situation where our vertex is outside of the circle. So this is going to be the 1/2 the difference of the arcs. So we're going to take 1/2. Here are our 2 arcs. The difference between them is going to be 100. 1/2 of 100 is 50. Okay? So one of these is a tangent line. One of these is a secant line. But I want you to keep in mind that the formula doesn't care. It works for either case, whether you have a tangent, secant, or one being a secant, one being a tangent, as long as the vertex is outside of the circle. For this last one here, we have 2 secants. Excuse me, 2 tangents, because they're both just touching. And our vertex is outside the circle, so it's going to be 1/2 the difference. If this arc is 140, that arc has to be 360 minus 140. So it has to be 220, that arc. And then since we're dealing with an angle that's outside our circle, we're going to take 1/2 the difference. So 1/2 of 220 minus 140, and we're going to get 40 degrees. One thing I want you to note that you may have noticed that is true is if you have this specific situation, this angle and the closer intercepted arc are going to always be supplementary. They're going to add up to 180. Now this only applies with two tangent lines, and I like to say it only applies when it looks like an ice cream cone. Okay, so as soon as something went like that, it would no longer apply, but as long as it's just two tangent lines, it works. Okay, let's go through a few more here. We're dealing with a picture where our vertex is outside of the circle, so it's going to be 1/2 the difference between these two. So 1/2 the difference between the two arcs must equal the angle. Solve that, you get that x is a 30-degree angle. Okay? Our pictures are obviously going to get more complicated as we go through this. So just start kind of like we did when we did our angle problems originally at the very beginning of the year. Fill in information that you know is true and see where it leads you. So if that's 20 degrees, that arc there must be 40 degrees. If this angle is 80 degrees, this arc must be 160 degrees. And now if we look at angle x, it is outside the circle, so it's going to be 1/2 the difference between the intercepted arcs. There's the one intercepted arc, the green is the other. X is going to equal 1/2 difference. So x is going to be 60 degrees. Cool. Same kind of thing here. Let's start filling in some information we know. So if this is 28 degrees, it is an inscribed angle. So that arc's going to be 56 degrees. Looking at this picture, this angle is supplementary to this angle. So that angle there is going to be 120 degrees. We can then determine that this angle is going to be 32 degrees because they're all in a triangle. And then if we look over here, 32 degrees is an inscribed angle for that arc. So that arc must be 64 degrees. And now if we go over here to what we're trying to find, x, we have enough information. It's outside of the circle, so we're going to do the difference, 1/2 the difference between green and red, so 1/2 the difference between 64 and 56. It's going to tell us that x is a 4-degree angle. Last one here, there's a hard way, there's an easy way. Hard way is, if this is x, then that arc has to be 360 minus x, and 50 has to equal 1/2 of 360 minus x minus x. And you can solve that and get that x is 130. Or you can remember that this is ice cream cone and say, oh, so the angle and the close arc have to be supplementary, so the close arc is 130 degrees. If you remember that ice cream cone thing, it'll save you some time. Okay, just want to do a couple more here. So if we look down at 14, this angle is 105 since they're supplementary. Our vertex is inside the circle, so it's going to be half the sum. So 105 is going to equal 1/2 of the sum of the two arcs, because remember these are our two arcs. Solve that, we get x is a 110-degree arc. Okay, and then I want you to go ahead and do 13 and 15 and come in tomorrow and we'll talk about them. A hint for 15, start by finding that angle there. And with that, we've kind of rounded out 10.5. We've kind of gone full circle with it, and maybe we'll circle back to some of this later. Have a good day.